So in previous videos we had discussed on electrostatic potential. So in today's class just we will discuss some numericals related to electrostatic potential and capacitance. So already we had discussed on electrostatic potential, so let me focus on electrostatic potential concept. So related to that electrostatic potential we will solve some numericals here. So I will read out the question. Electric potential decreases uniformly from 120 volt to 180 volt. So electric potential is decreases from initial voltage is 120 and it will decreases to 80 volt here. As move on x-axis from x is equal to minus 1 centimeter to x is equal to plus 1 centimeter. So initially x1 is minus 1 centimeter and x2 is plus 1 centimeter. Find the electric field at the origin. So which thing I need to find out here? Electric field. What is the connecting formula between potential, distance and field here? So E is equal to what? So E is equal to minus of dV divided by d of r here. So E is equal to, so dV shall I write it as a V2 minus of V1 here. So d of r or d of x I will take it here. So this will be d of x. Shall I write this one as a x2 minus of x1? Then E is equal to minus V2 means how much? 80 volt. V1 is 120 volt divided by x2 value is how much? Plus 1 centimeter minus of x1 is what? Minus 1. So minus into minus. So shall I take this one? 1 plus of 1. So minus of. So 80 minus of 120. So that is minus of 40 divided by 2 here. Negative, negative. So minus into minus plus here. So that is 20 Newton per coulomb, or another unit is 20 volt per meter. What is that electric field here? So electric field is 20 volt per meter here. Sorry, this is 11th question. Okay. So here in terms of centimeter is there, volt per centimeter you may make it otherwise. So next one, a charge of 5 coulomb experience a force of 5000 Newton here. What is the magnitude of the charge? Charge of 5 coulomb, it will experience a force of 5000. So that is 5 into 10 to the power of 3 Newton here. When it is moved in a uniform electric field, the potential difference between the 2 points separated by a distance of 1 centimeter here. So distance value is how much? 1 centimeter. So which thing I need to find out here? So I need to find out that potential difference value or V value. So distance value how much they mention? 1 centimeter. Okay. So first let me find out that field value, then I know that relation between field and force. E is equal to what? So E is equal to, so F by Q here. So what is the connecting formula here? E is equal to F by Q. Force is 5 into 10 to the power of 3. Charge value is 5 coulomb. So electric field value is 10 to the power of 3 Newton per coulomb. So potential value. So E is equal to V by D. So just I will take that magnitude here. So V is equal to E into D here. So V is equal to, E value is how much? 10 to the power of 3. So distance value is how much? 1 into 10 to the power of minus 2. So 10 to the power of 3. So 10 to the power of 3 minus 10 to the power of 2 here. So that is V is equal to 10 volt. What is the potential value here? So potential difference value is 10 volt here. So we'll look at that next one. There is an electric field in positive x direction. What is the direction of electric field? Positive x direction. If work done on moving a charge of 0.2 coulomb through a distance of 2 meter here. So look at here. So electric field is along positive x axis. So what is the work done in moving a charge of 0.2 coulomb? What is the magnitude of charge here? 0.2 coulomb, or 2 into 10 to the power of minus 1 coulomb. Moving through a distance of 2 meter. So how much distance it is moving here? Moving through a distance of 2 meter. Along the line making an angle of 60 degree. So what's the angle it will make here? So theta value is 60 degree with positive x-axis, and so that work done is 4 joule. So work done value is 4 joule. Then value of E is, so look at here. So one charge particle is there. The charge particle is moving along that positive x-axis they mention here. So direction of electric field is along positive x-axis. So in that electric field they will place one charge particle. Its magnitude is 0.2 coulomb and it is moving through a distance of 2 meter. Then what will be the magnitude of electric field I need to find out here. So work value they mention, and so angle value they given, distance is also they mention. So I need to find out that electric field value here. So first let me find out that work done here. So work done is equal to what? Force into displacement, F into S cos theta here. So look at here, work done is equal to F, shall I write it as a E into Q here? E into Q into displacement into cos theta. Work done is how much? Work done is 4 joules. So E value is yet to be determined here. What is the magnitude of the charge? 2 into 10 to the power of minus 1. What's the distance? So that is 2 meter. So cos of 60 degrees. So that is 1 by 2. Cos 60 value is 1 by 2. 2 ones are 2 twos are. E is equal to what? So divided by 10 to the power of minus 1. So E is equal to what? So 2 into 10 to the power of 1 or 20 volt per meter, or another unit is 20 Newton per coulomb. What is that electric field value here? 20 Newton per coulomb here. So we'll look at next one. Okay. Electric charges plus Q, and minus 2Q are placed at the corners of equilateral triangle ABC of side 1 meter. The magnitude of electric dipole moment of the system is, so what is the dipole moment? P is equal to Q into 2L. So that is applicable for, so 1 plus Q charge, another one is minus Q charge. Here 3 charges they mention, one is plus Q, another one is also plus Q, and minus 2Q. So this situation I will name it as a quadrupole. So in that first chapter already we discussed the concept related to quadrupole. What is the equation for momentum in case of that quadrupole? So 15th one. So momentum in case of quadrupole, that is P dash is equal to P into, so P dash is equal to, so 2P into cos of theta by 2. So what is the dipole moment in case of that, what is that dipole moment in case of that quadrupole here? So in case of that quadrupole, so P dash is equal to 2 times of P here. So P is equal to what? Q into 2A here. So shall I write this equation as a 2 Q into 2A into cos of theta by 2. So what is the charge value? Q here. Magnitude of the charge. What is the distance value? 1 meter they mention. And what's that angle? Equilateral angle means 60 degrees. So 60 by 2. So that is 30. Cos of 30 degree here. 2 into Q into 1. Cos 30 value is how much? Root 3 by 2. So P dash is equal to root 3. So this one is 1 meter into Q here. So what's the answer here? Root 3 Q into 1. So root 3 or, so root 3 Q into 1. So this is the dipole moment. So in case of that charges, if there is a more than 2 charges, so that I will name it as a quadrupole here. So in case of that quadrupole, this is the formula to determine the momentum here. Sorry, this is the formula to determine the dipole moment. So we'll look at that next one. So that is 16th one here. Electric intensity due to a dipole of length 10 centimeters. So that don't get confused here. So most of you are getting confused. Dipole length is 10 centimeter they mention, means 2A is equal to 10 centimeter. Some of you are thinking that A is equal to 10 centimeter. It's not like so. Dipole length is 10 centimeter means 2A is equal to 10 centimeter. or 10 to the power of minus 1 meter here, and having a charge of 500 microcoulomb. What is the magnitude of the charge here? 500. 5 into 10 to the power of 2. Micro means 10 to the power of minus 6 here. Shall I take this one as a 5 into 10 to the power of minus 4 coulomb here? At a point on the axis at a distance 20 centimeter from one of the charge in air is. So I need to find out that electric field at a distance of 20 centimeter from one of the charge. So that distance, let it be r dash, so that is 20 centimeter. So look at here, they mention that the electric intensity due to a dipole of length 10 centimeter. So look at here. So dipole means it must consist of one positive and another one is negative here, and its dipole length is so 10 centimeter. What is the dipole length here? Dipole length is 10 centimeter. So they asked to determine that what is the electric field intensity at a distance of 20 centimeter from one of the charge. So r dash value is how much here? R dash value is 20 centimeter from the one of the charge. So this is related to that electric field at axial line. In that first chapter I derived the expression for electric field at axial line. What will be the equation for that electric field at axial line here? E axial is equal to 1 by 4 pi epsilon naught 2 pr divided by r square minus of a square whole square here. What's that r represents here? So r represents that point of observation from the center of the dipole. But in that question they mentioned that at a distance of 20 centimeter from one of the charge they mentioned. So it means that, so r means shall I take from that of center of the dipole. So then what is the distance from that center of the dipole to point of observations? This total distance is 10 centimeter, means this distance is 5 centimeter. Then what should be the value of r here? So r is equal to here 20 centimeter and here 5 centimeter. That is 25 centimeter. So look at the question here. They mention distance from any one of the charge from that plus q to point of observation is 20 centimeter. But from the formula, so r is represents that distance from that center of the dipole to the point of observation. Then what is the answer here? So r value is 25 centimeter. So let me fill the value here. Electric field at axial line 1 by 4 pi epsilon naught is 9 into 10 to the power of 9, 2 here. So P is nothing but what? P is equal to Q into 2A here. So what is the magnitude of the charge here? So 5 into 10 to the power of minus 4. So 2A value is how much? So 10 to the power of minus 1. So 2 into, so P is nothing but what? Q into 2A. Q value is how much? 5 into 10 to the power of minus 4. 2A value, dipole length value is 10 to the power of minus 10 here. Sorry, 10 to the power of minus 1 here. R value is how much here? So R value is 25 centimeter. Don't take it as a 20. So that distance is from one of the charge from the center of the dipole is 25 centimeter here. So 25 into 10 to the power of minus 2. So divided by R square means how much here? So R square means 25 into 10 to the power of minus 2 whole square. R square minus of A square. So 2A is how much? 1 into 10 to the power of minus 1. A is equal to what? 0.5 into 10 to the power of minus 1 or 0.5. So look at here. So 10 centimeter, or look at here. So 10 centimeter they mention. So 2A is equal to 10 centimeter means A is equal to what? 5 centimeter here. So A is equal to what? 5 centimeter here. So 5 into 10 to the power of minus 2. So whole square. So finally this is the formula. So let me fill the value here. So look at the denominator value. So 9 into 10 to the power of 9. 9 into 10 to the power of 9. So 2 into 5, that is 10 into 10 to the power of minus 4 into 10 to the power of minus 1 into 25 into 10 to the power of minus 2 divided by 25 into 25. So that is 625. 625 minus of 5 into 5, 25. 10 to the power of, so 10 to the power of 2 minus 2 whole square, 10 to the power of minus 4 here. So that is whole square. So look at here, electric field at axial line is equal to 9 into 25 into 10 to the power of 9. So look at here, this is 10 to the power of 1. So 10 minus of 5. So 10 to the power of 10 minus of 5 here. So 10 to the power of 5 here. So this is minus 2. So that is 10 to the power of 3 here. So 10 to the power of 3 divided by, so 625 minus of 25. So that is 600 into 10 to the power of minus 4 whole square here. So electric field at axial line is equal to 9 into 25 into 10 to the power of 3. So look at here. So 600 into 600 into 10 to the power of minus 8 here. So look at here. So that is 25 into 10 to the power of 3. So 200 into 200, that is 4 into 10 to the power of 4 into 10 to the power of minus 8 here. So 25 divided by 4 into 10 to the power of 3. So that is minus 4 means that is plus 4 here. So if it goes to numerator, so electric field at axial is, so 6.2 here. So 4 ones are 4 6 are here. So it is around about 6 point something here. So 6.2 into 10 to the power of 7 Newton per Coulomb. So look at here, what is the answer here? 6.2 into 10 to the power of 7 Newton per Coulomb. So look at here, somewhat the difficulty in the question is r dash value. So from one of the charge is 20 centimeter. So usually we will fill that value, r value as a 20 centimeter means, so you won't get the answer. So just read out the question clearly. They mention that, so point of observation is at a distance of 20 centimeter from one of the charge they mention. So but r value is, so from the center of the dipole, so from the center of the dipole value is 25 centimeter here. So we'll look at next one. Okay. The potential due to the electric dipole at a distance r from the dipole on axial line is, so they asked to determine that what is the potential in case of a axial line. What will be the equation for electrostatic potential due to dipole here at any point due to dipole? So that is P cos theta divided by 4 pi epsilon naught r square. Hope you remember this equation. So we derived that expression. So had derived in previous videos. So electrostatic potential at any point due to dipole. Here where is the location of point they mention? Axial line. So at axial line means what's the theta value? 0 degree. So potential at axial is, so P into cos of 0 degree 4 pi epsilon naught into r square. So I shall rearrange this equation. P means dipole moment here. So shall I take it as a Q into 2A here? 1 by 4 pi epsilon naught. P means what? Q into 2A divided by r square. So this is the required expression for that electrostatic potential in case of a axial line here. So we'll look at next one. So for dipole, Q is equal to 2 into 10 to the power of minus 6 coulomb. So for a dipole, what is the charge value? 2 into 10 to the power of minus 6 coulomb here, and it is at a distance, means dipole length value is 0.01 meters. So D is nothing but a 2A here. 0.01 meter. So shall I take it as a 1 into 10 to the power of minus 2 meter here? Calculate the maximum torque for this dipole. So which thing I need to find out here? Maximum torque for this dipole, and this dipole is placed in an external electric field value. Its magnitude is 5 into 10 to the power of 5 Newton per Coulomb. So what is the generalized formula to determine the torque here? Torque tau is equal to P sin theta. Maximum means theta value is how much? So that is 90 degree here. So torque tau is equal to P means shall I write it as a Q into 2A here into, so sine of 90 degree means 1 here. Magnitude of the charge is 2 into 10 to the power of minus 6 here. So 2A value is, so 10 to the power of minus 2, and electric field value is 5 into 10 to the power of 5 here. So torque tau is equal to, so 2 into 5, 10 here into 10 to the power of minus 8 plus 5 here, so that is minus 3. So 10 into 10 to the power of minus 3, I will write it as a 10 to the power of minus 2 here. So what is the answer here? So 10 to the power of minus 2 Newton meter here. So 10 into 10 to the power of, 10 to the power of minus 2. 1 second here. So look at, so torque tau is equal to how much here? So 2 into 5. So that is 10 into 10 to the power of minus 8 plus 5 here. So torque tau is equal to 10 into 10 to the power of minus 3 here. So what is the answer here? 10 into 10 to the power of minus 3, that is 10 to the power of minus 2 Newton meter here. So what is the answer here? So 10 into 10 to the power of minus 3, so or 10 to the power of minus 2. So let me check out the answer. So 18th one. Okay, so 10 into 10 to the power of minus 3. In that option, 10 into 10 to the power of minus 3 is there. 10 to the power of minus 2 is not there. So what is the answer here? 10 into 10 to the power of minus 3 here. So we'll look at next one. Okay, we'll look at the next one. 2 point charges minus q and plus q are located at a points 0, 0, minus a. So negative z axis, and another charge plus q is at a distance of 0, 0, a, positive z axis respectively. Potential at a point 0, 0, z is. So I need to find out the potential at 0, 0, z at the origin. So 1 by 4 pi epsilon naught. So for a system of 2 point charges, for example for plus q charge, so plus q charge, what is the distance here? So 0, 0, a here. So from the center, so that is z minus of a here, minus of, so for negative charge here, so plus into minus, so that is minus here. So minus of minus, so that is plus of a here. So look at here. So negative charge is at a distance of minus a here. So minus into minus what? So that is plus here. So look at here, 1 by 4 pi epsilon naught. Shall I take that, say this one as a plus b into a minus b. So that is a square minus of b square here. So if I take that LCM, so a square minus of b square, so that is z plus of a minus of q into z minus of a here. So look at here, 1 by 4 pi epsilon naught. So that is z square minus of a square here, q into z plus of q into a minus of q into z. So if you remove that bracket here, so minus into minus what? So plus here. So that is plus of q into a here. So plus q into z minus q into z will getting cancelled out here. V equal to 1 by 4 pi epsilon naught, q into a plus q into a. So shall I take the 2 times of q into a divided by z square minus of a square here. So 2q into a, so 2a into q, so that is nothing but what? So that is dipole moment here. So what shall I take it here? Dipole moment, or in that option they left it as it is, 1 by 4 pi epsilon naught 2qa divided by z square minus of a square. What is the potential at point z here? 2qa divided by 4 pi epsilon naught. So sorry, v is equal to 1 by 4 pi epsilon naught 2qa divided by a square minus of z square here. So we'll look at that next one. Okay, a molecule with a dipole moment P is placed in an external electric field strength E. The initial dipole is aligned parallel to the field. What is the initial angle between that dipole and that of electric field? Parallel means its value is 0 degree. Theta value is 0 degree. If the dipole is to be rotated to be anti-parallel to the field, anti-parallel means what here? So theta 2 is equal to 180 degree here. Work required to be done by the external agency here. So work done, shall I take it as a P into E cos of theta 1 minus of cos of theta 2. So we derived this equation. Work done to rotate the dipole, that work done is stored it as a potential energy. P into E. Initial angle is how much? 0 degree. So I will write that cos of 0 degree here minus of cos of 180 degree. So this equation becomes, so P into E. Cos 0 means how much? 1 minus of cos of 180 means how much? So that is minus 1 here. So work done is equal to P into E. So minus into minus, so plus. So that is work done is equal to what? Work done is equal to 2 times of P into E here. What is the work done here? Work done is 2 times of P into E here. So we'll look at next one. Two charges plus 3.2 into 10 to the power of minus 19 coulomb and minus 3.2 into 10 to the power of minus 19 coulomb are placed 2.4 angstrom apart from the electric dipole. So they mention magnitude of the charge. So that is 3.2 into 10 to the power of minus 19 coulomb, and it is another one is minus 3.2 10 to the power of minus 19 coulomb, and it is separated by a distance of 2.4 angstrom unit here. So 2.4 angstrom unit here. So 2.4 into 10 to the power of minus 10 meter. It is placed in a uniform electric field of intensity. So that dipole is placed in a uniform electric field intensity. So that is 4 into 10 to the power of 5 here. E value is how much? 4 into 10 to the power of 5 volt per meter. The electric dipole moment is, so which thing I need to find out here? Dipole moment. What is the connecting formula? Q into 2 of A here. Q value is how much? So 3.2 into 10 to the power of minus 19. So 2A value is how much? So that is 2.4 into 10 to the power of minus 10 here. So 3.2 into 2.4. So what's the answer here? So 3.2 into 2.4 here. So 768 into 10 to the power of minus 2 here, 10 to the power of minus 19 minus 10 here, minus 29 here. So P is equal to how much? 768 into 10 to the power of minus 31. What is that SI unit for the dipole moment? So coulomb meter here. So coulomb meter. So in that option, so I will rearrange here. So 7.68 into 10 to the power of minus 29 coulomb meter here. What is the answer here? 7.68 into 10 to the power of minus 29 coulomb meter here. Okay, we'll solve next one. Okay, look at here. The potential at the origin is 0 due to a electric field. So what is the potential value at the origin here? 0. Due to the electric field value they mention. So that is 20 I cap plus of 30 J cap Newton per coulomb here. The potential at point P is, so the distance, so what will be the potential at point P? 2 comma 2 here. So which value I need to determine here? Potential at point P. So that point P is at a distance of 2 meter and 2 meter from that of origin here. So from x axis 2 meter and from y axis is also 2 meter here. So in order to determine the potential value, minus of E into d of R here. So look at here, minus of, what is the value of electric field here? 20 I cap plus of 30 J cap here. So what is the R value here? So 2 comma 2. So along x axis 2 meter and along y axis is also 2 meter. V is equal to minus of 20 into 2, 40 I cap plus of 30 into 2, 60 J cap here. So V is equal to how much? So that is 100. So minus of 100 volt here. What is the answer here? Potential value is minus of 100 volt here. So we'll look at next one. Two conducting sphere of radius R1 and R2. So two spheres are there. These radius they mention as R1 and R2 are at a same potential. The electric intensity on their surface are in the ratio of. So which thing I need to determine here? Electric intensity in terms of ratio here. So what is the connecting formula between electric field and the radius here? So look at here, so relation between field and potential. So E is equal to what? V by D. So magnitude, if you consider, means distance is nothing but a radius here. So electric field is inversely proportional to radius. So shall I take this one as a E1 by E2 is equal to what? R2 by R1.